Hey guys, just very quick video on logic, because I think there is a couple of things that we skipped when we started talking about the logic, and because logic comes back when you're programming as well. It's one of the key things you need to understand when programming. I think it's good if you try to understand it the way I understand it, and hopefully that's going to help you. So I'm not going to go into too many details. I just want to see if you like what I'm saying, if you like the way I approach it. Maybe I can make a couple of more videos like this. So just let me explain it in very easy way. So we have Boolean logic, which means Boolean means it's either 0 or 1. It's something about the binary system. So it's either 0 or 1, or you can call it false or true. Yeah, so 0 is false, 1 is true. And we have our three basic operators, which are AND, OR, and NOT. And there is also XOR, NAND, and NOR. So we can start with AND. So there's A dot B, and that's you read it A and B. And there's OR, so there is A or B. And this is tricky because sometimes you explain something, or someone or the lecturer will be explaining something, and this we associate plus with AND. Sometimes we say 1 and 2 equals 3, yeah? But this isn't AND, this is OR, and it's very important. And it's put this, they used a plus sign for OR for a reason, and you'll see later, not in this video, but you'll see why that's easier to understand, to remember and use in the future. There's not, so we indicate not with the bar, or sometimes you can see A prime, but usually if you hear A bar or A or B bar, it means not the result of this. You'll see later. There is XOR, which is exclusive OR, and you put a plus sign and a circle around it, and it's exclusive OR. And there's NAND, and there's NOR. So NAND is basically an opposite, and not result of A and B. So if the A and B equals 1 in certain situation, then in the same situation, if we put a bar above it and take the NAND of it, then we take 0. So if AND is 1, then NAND is 0. If OR is 1, then NOR is 0. And the opposite, if OR is 0, then NOR is 1. It's always flipping. It's very easy. So let me see if you can see it. Yeah, great. So for AND, I like to see it not as 0 and 1, which computer can understand zeros and 1. It doesn't know what the true and what false is. It understands zeros and ones. And we agreed kind of 0 is false and 1 is true. So, but now if you look at the logic in the false true way, maybe it's a bit easier. Then actually it is logic. It is logical to you. So imagine, let's think about AND operator. So if there is a guy which is shorter, and it's a blue guy, sorry, this is the taller guy, this is the shorter guy, he's not going to talk, the big guy will be talking now, and it's a blue guy. And if that guy says, I am taller and I'm shorter, that doesn't make sense, that's false, that altogether it's false, it doesn't make sense, right? So that equals false, yeah, 0, that equals false, that's yes, 1, of course that's true, but that's 0, that's false. So altogether 1 and 0 is 0, because altogether it doesn't make sense. Okay, so in second option here, second situation, I am taller and I am blue. Okay, that's true, you are taller and you are indeed blue. Okay, that's fine. So that altogether, that makes sense. I'll say this is 1. And then I am shorter, no you're not. And I am black, no you're not. Both are wrong, so that's obviously wrong, that's false, yeah? False and false equals false, yeah? So if you look at the truth table, You've seen them before, so let's say we have A, sorry, you have to go one higher, A, B, and A and B, yeah? A, B, A and B. If it's true and true, true and false, false and true, false and false, yeah? If it's both true, only then this is true. Otherwise, if that's false, here it's 0 and that's 0 and that's false and true, so that's altogether it's false, and both false, it's false, yeah? And as I said before, we use this, it looks like multiply, and indeed if you multiply, if you look at this as, you know, the previous arithmetics, the node that we know, the one that we know from school, 1 times 1 is indeed 1, and then 1 times 0 is 0, 0 times 1 is 0, and 0 times 0 is 0. So that's easy to remember, even if you kind of just go back in your memory to school. Okay, or, so or is our plus sign, yeah? And it works like this: I am taller, true, or I'm shorter. Yeah, altogether it's true. You are either taller or shorter. There's no other way. And that's altogether is true. You are taller or shorter. You are actually taller. But that all statement is true. You are taller or shorter. Okay, I am taller or I'm blue. True, yeah, you are taller or you're blue. Yeah, well, you're actually both. But in this case, if it's not exclusive or, you can actually say everything is true and it's still true, yeah? It kind of doesn't sound great when you say I'm blue or I'm taller. It's both true, but it's still true. If it's true, then it's true, yeah? In or, not XOR. XOR makes a bit more sense to our logic. And then I'm shorter, no you're not, or I'm black, no you're not black. So that's 0, that's 0, so altogether it's 0, yeah? It's false, that's false, so altogether it's false. And again, if you look at the truth table, it's true, true, false, true, true, false, false, false. That will be true because one of them, at least one of them is 1, and actually in this case is both. 1 is true, yes, there is one that is true, but these are not true, so that will be 0, yeah, that will be false. In OR, and there is this XOR guy, which is exclusive OR, and it makes a bit more sense. So let's go here. I am taller, yes. XOR, I'm shorter. No, you're not. So you are taller, you're not shorter, so that makes sense, yeah? For XOR, just one guy, one literal, in this case, one kind of statement is true, rest of them aren't true, and that's the only positive result that will yield that's the only kind of situation where the XOR will yield the true result. So let's look here. I am taller, yes, and I'm blue, yes. So if I put XOR in here, kind of, I'm either taller or I'm blue. No, you're both. So that statement doesn't make sense. So in this case, it will be 0. That will be false. And it's kind of more. It makes sense more to our logic. Yeah, I'm taller or I'm blue. No, you're both. So it kind of tells you no, there's something wrong. So that's how XOR works. And then if they're both false, yeah, I'm not shorter, I'm not black. That's 0 as well, because none of them is true. So that's it. If you want to know more a bit more about NAND and NOR, it's basically just opposite of AND and opposite of OR. So if there is a NAND of something that is true and is false, so in AND it gives you 0, then NAND give you 1. And if you have true and true, so in AND AND will give you 1, that will give you true, then NAND will give you 0, and so on. So that will be just flipped 0, 1, 1, 1. And in here, NOR, yeah, not OR, will give you 0, 0, 0, 1. That's it. So if you look just very quickly on the postulates, so there are postulates and there are theorems. I won't be talking about them for too long. There are two kind of different. Oh, did I move it? Yeah, a little bit. There are like two different sections: postulates and theorems. The best way to do it is to remember it, and the easier way to remember it is to kind of give it a logic. If you understand the logic, it's easy to kind of say, okay, so OR works like this. I have A, and if I OR it with 0, it gives me A. Okay, why is that? Okay, so right, so one of them is negative. I know that one of them is false. Okay, but there's still A. It's still A will still give me an answer. So either if it's false or true. Okay, so if it's false, then this is false. If A is true, then altogether it's true. So that makes sense. That 0 doesn't matter here, because if you OR something with 0, it still gives you an answer. The answer is still based on the other literal. Yeah, so it doesn't matter if you put that 0 here or not. On the other hand, if you go for where is it? Is that the one? Well, kind of additionally you can say, I'll add just this, if there's A and 0, so always false. Yeah, I just gave you the answer. It will be always false, yeah, because no matter what I'm gonna say, there's also put into AND bucket false. So it's gonna say no, there's one false answer, so it's always false. There's no other way around it. And again, this nice little dot that reminds us of 0 kind of gives you an answer, because in school we said something times 0 equals 0, yeah? So that's easy to remember. And that's kind of the same. If you said, okay, 5 plus 0 equals 5, yeah? It doesn't matter if you put that 0 there or not. And so on. And then again, if you look at this guy, if you OR something with its opposite, with its not, then it's always true. Yeah, it's the same situation as with the guy who is saying, I'm taller or I'm shorter. This is opposite. These two are opposite to each other. This is A and this is not A. Yeah, sorry. This is not A. If you OR it, it will always be 1, because either way, one of them is 1. One of them is true. And so on. So you can use that logic, something I just explained to you, and kind of look at this and see, yeah, that makes sense. That makes sense. And also, if you look here, you also should be able to kind of understand, using these postulates, you should be able to see that these theorems are true. Okay, I hope that kind of gives you a bit more clarity on logic. If the way I explain it makes sense to you, and you would like to see more about, let's say, that doesn't make sense, but about the gates, and maybe just go through a couple of tutorials that Andriana uploaded on web courses, I will be glad to do it. Just let me know if you're interested. Thank you for watching, and good night.